Alright, let's review what the x-y coordinate plane really represents. It shows the relationship between any 2 points, describing their positions and lines, and as well as the parabolas, logarithm, and exponential functions we will learn later. It all describes the direct relationship between the x and y coordinates of any point. Now let me write a classic line we've learned before. Y equals x. It means for any point, the x coordinate equals its y coordinate. After drawing this line, I will draw another line, x equals 1. This line means x coordinate of any point on it is 1. So here, you see, these seem to interact together, right? So what's their intersection and what does that mean? Well, this intersection point lies on both y equals x and x equals 1. It's on both equations. So it must satisfy both. And let's write them together. Y equals x and x equals 1. It satisfies them together. Let's substitute y equals x equals 1 into the straight line. It seems like y also equals 1. So the point 1, 1 is the intersection of the line y equals x and the vertical line x equals 1. This principle is that the point's coordinate must satisfy both equations y equals x and x equals 1. And let's quantify this with another example. Take the line y equals x plus 1. Its intersections with the x-axis and y-axis can be seen as intersections with x equals 0, this vertical line, and y equals 0, this horizontal line. So how to find their intersections? Well, as for point A, it must satisfy y equals x plus 1, this straight line, and x equals 0, this vertical line as well. So if we combine them together, we will find y equals 1, x equals 0. So the point is 01. And as for point B, it must satisfy y equals x plus 1 and y equals 0, both of the lines together, because the point lies on both of the two equations. So when I substitute the value of y equals 0 here, we could find y equals minus 1. So the coordinate of B is 0, minus 1. And now we understand the relationship between the line and the axis from the perspective of intersections. So what if we have two different lines? For example, the first line will still be y equals x. The second line is y equals minus x plus 1, and I draw them together. So the first line will be looking like this. The x coordinate is y x coordinate, and the second one is starting point is 1 and its slope is minus 1. So I will draw it like this way. So how do I figure out their intersection here? Still, it's a point that lies on both of the equations, so it must satisfy both. And if I combine them together, well, they share the same value y and the same value x, which means I could substitute the second equation into the first one, because y is x and x is also y. So x equals minus x plus 1, and I will get x equals 0.5. So y equals x, so y is also 0.5. And successfully I will get the coordinate of their intersection here is 0.1, 0.5, and 0.5. So this is their intersection. And now, if I just give you two equations out of the picture, y minus x is 0 and y minus 2x is 1, and ask you to solve the system, it gains a new meaning. Well, because when you're trying to solve this with coordinate system, and you convert them into y equals x and y equals 2x plus 1, if you immediately be the question that we're confronting right now. We're trying to figure out their intersections. So this has given us a whole new picture. The simultaneous equations that we solved before actually means a geometry problem. We are just trying to find the intersections of two lines or maybe a parabola with two straight lines. But anyways, it can be solved with x or y coordinate system. This insight here is just that we can either solve the dry algebraic equations or draw their graphs to visualize the intersection. That's the real meaning of their solution. If we actually need the intersection coordinates, we can set the equations equal. Just directly link them. This uses the true meaning of the x or y coordinate system. Any point on it describes its potential relationship relative to the origin, and any function expression describes the relationship between its x and y coordinates. Let's do one more specific example. Find the intersection of the lines y equal 2x plus 1 and y equals minus x, and how? So first, we still need to draw the x or y coordinate system, but well, I don't think I need to do the unit length here. Well, as you know, it's just a system. And I draw two lines, y equal minus x, so it will still pass the origin with negative value slope minus 1, and y equals 2x plus 1. It has a starting point 0,1, and with a bigger angle of inclination. So here, you see they do have one intersection here. But how do we solve it? Still, it lies on both of the straight lines, so it must satisfy both of the equations. And when I list them together, they share the same value of x and y, which means I could substitute any one of them into another. So I substitute the second equation, y equals minus x, into the first one. So it will be minus x equals 2x plus 1. So solving it, I will get 3x. Oh, it's not 3x, it's 3x minus equals minus 1. So x will be minus 1/3. So I have known the x coordinate, so the y coordinate will be 1/3. So the coordinates of point A would be minus 1/3 and 1/3. And that's how I solve, and that's how I find the intersection between the two lines. After learning all about this, the next lesson will cover parabolas. Let me just briefly review. Why is a line and a parabola a parabola? What is the fundamental difference between them? Why is a straight line and a parabola curved? I will give you the answer next time. For now, I hope everyone can understand deeply about the relationship between the x and y coordinate system and lines. This knowledge is the key to progressing to the next topics. And see you next time.